Hey guys, there's two types of waves we're going to deal with, and the first one is called a transverse wave. This means that the medium, that stuff that the wave is going through, it moves perpendicular when the wave passes. It moves perpendicular to the direction of the wave. So if the wave moves to like left to right, then the medium will move up and down. At a right angle to the way the wave moves. Some good examples of this are a stadium wave. You know, if you've ever been in a sports stadium when they do the wave, what happens is the wave moves left to right, while the people who are like the medium that the wave goes through, the people move up and down. All right, and it actually kind of looks like a water wave when it's going on. And if you could take the stadium wave and say like, the people are the water molecules, and the wave goes through them. That's exactly what happens in a water wave. Is the water molecules, they stand up and they sit down while the wave goes through them. So here's a diagram of a transverse wave. Okay, it ends up looking like that. And you've seen that kind of shape before, like a sine wave or cosine in math class. And you could kind of pretend here. This is called technically the line of equilibrium. I'll repeat that in another video later. That's where the water is when there's no waves. And if here's a water molecule, the top there, it was like the person in the stadium. It sat up, and then later on that water molecule will sit down. It moves up and down, but which way is the wave going? Left to right, perpendicular to the way the water molecules are moving. So that's a transverse wave. Now, the second type of wave, let's get this out of the way, is called a longitudinal wave. All right? A longitudinal wave means that the medium moves parallel. It's the only difference, really, from transverse. Now the medium moves parallel to the direction of the wave. Our main example of a longitudinal wave, you can make both of these with slinkies, which we'll do. But the main example is a sound wave. All right. In sound, the medium, that's like the air molecules. You know, if the sound is going through air, the air moves. Each molecule will move forwards and backwards instead of up and down, like a water molecule will in a transverse wave. So the sound wave goes through the air, and whichever way the wave is going, that's the way the air molecules move. All right, and it makes this kind of cool shape here, and we saw this in another video, where we kind of, as those molecules move forwards and backwards instead of up and down, what they do is they compress and they stretch, like a slinky. So this is a compression when the molecules move forward. And right next to each compression is a low pressure area. So compression, it's just that high pressure. There's a lot of air molecules in that area. And for a longitudinal wave, all longitudinal waves also have something called a rarefaction. New word, definitely, for most of you, and that is a low pressure area. So it's kind of like where, you can think of it like a slinky, each air molecule like a slinky. Here's the slinky, is the coils are together, then they're apart. So that it's like the air molecules work the same way. They're together, and then the air molecules stretch apart. Because what they're doing is they're really moving backwards and forwards as the wave goes through it, right? So, this is your diagram of a longitudinal. Sometimes the people, in fact, they call it a compression wave, longitudinal or compression wave, where each molecule moves forwards and backwards. I mean, just think about it. Like, why do the molecules move forwards and backwards? It's because originally, what did the speaker do? The speaker pushed in and it went out. The speaker's not pushing up and down, you know? So the reason why the medium moves parallel on a longitudinal wave here is because that's the way they're being pushed by the vibrating speaker or whatever vibrating object is making it. The vibrating object pushes in, makes a compression, pulls out. And it just so happens that when it does that, the medium moves parallel to the way the wave moves. But I mean, think back to a transverse wave. Why is that different? Why does the medium move perpendicular to the wave? I mean, how do you create a water wave? How do you create this transverse water wave? You have this hand, and which way do you hit the water? You hit the water down, maybe with a boogie board or something like that, and that's how you make a water wave. You don't push this way. You don't push parallel to the way moves. That's not going to make a water wave. You push up and down, and then the wave goes left to right. So the way the medium moves is really a product of how you pushed it in the first place.